we are expecting this. So 6 is represented as, correct? So what would be 1's complement?
1 and 1.
It will be 2's complement.
1
We will be adding a 1. No, that is
Correct?
correct.
And now we'll add 16 to it.
0, 0,
0,
0,
0, 0, 0, 1, 0, 0, 0, 0.
1.
0. Okay, this will be discarded.
This is dropped off.
And yeah, hold on a second. Subtracting 60.
Jesse, before we close the topic, one more example with 16 minus 22 or something like that. That
Negative?
thing.
Okay.
Is it 5 minus 12 resulting in minus 7?
Problem is to represent minus 7, it will come in a weird form. Because this is minus 6.
Yes. That's the that's the trick.
So it will not look minus 7, but you can verify it by putting it in your, if anybody has a computer.
You can actually do a reverse loop complement of that. And
But still it will not work. Okay. So we are doing 5 minus 12. Okay. So this is 12. 1's complement will be, 2's complement will be,
That is not 12. That is not 12. No, that is 12.
That is 12.
That is
this is 12.
This is
8,
11.
4, 2, 1. 8 plus 4 is 12.
Yeah, yeah. It's 10, it's 11, and 2 into 3. 1 more
100.
Okay. So now we will add to
7.
7.
5, sorry.
5. Whatever.
0,
0, 1, 0,
1, 0, 1, 0. So this is minus 12 and this is 5. So we should have got minus 7. Okay. So now we have 2's complement of
Correct.
this. So we are going to subtract 1. Okay. So this will look something like this. Correct?
yes. And then
0, 0, 0, 0, 0, 1, 1, 1.
that is 7.
4 plus 2, 6, 6 plus 1, 7.
So this is minus 7? Because
Yes.
this is first complement.
Because this is a 2's complement that we got.
We did minus 1, so it means that 1's complement.
This is
and
1's complement.
then-
And then this is the actual.
So this is the mask. We created
There is no mask here.
कैलकुलेशन है ना वो तो
Mask is
Mask is later on.
तो बोला थोड़ा ना देगा फुल कैलकुलेशन नहीं होता है
mask. We did negation. This is negation of first complement.
So that was minus 7, right?
This is minus 7.
What is the result?
This is a 2's complement of 7.
Okay.
We are, when you get this, you realize that this is actually a negative number. So you are trying to find its actual number. So you are reversing the polarity.
And the reversing of polarity is done by -1. That 2 is to
Now, this is 1's complement, and then you will actually reverse it again, bring it to its normal.
Nice example.
So this is not the -7, this is the positive +7. That is the
This is
difference.
plus
We are
7, this is
representing it
minus
as
7, yes.
yeah,
Yeah, we
plus
cannot
seven.
read this as
Correct.
minus 7.
Correct.
So.
Correct.
Just a minute.
Sure.
Done.
Nobody is going to ask you this. This is the basic concept we'll be using eventually. And actually, this is how the compiler calculates. When you ask the compiler to subtract two numbers, this is how it does it. And it doesn't do this. It will just figure out from here that this is minus. Right?
Yep.
We'll do multiplication and division by right shift. Bit shift. So when you want to look at a decimal number, 17. So decimal is a base of 10. When you left shift this, what will happen? This is empty, so you put in a 0. So this is
Yep.
essentially multiplied by 10
Yes, for one bit.
for one
One decimal place.
Decimal place.
Yep, yep.
When you're doing 17, you're doing a right shift.
That means 1.
So let's say you
One.
drop off whatever went.
Yep.
So this would be divided by 10.
Yeah.
This is modulo 10 actually.
Divide.
But since you are assuming that whatever is left over, the remainder is dropped off, this is still divided by 10.
Yeah.
So we can do the same thing for binary. So let's say we have, this is 2. When you left shift this, it will become 4. When you left shift this, it will become 8. When you left shift this, I'm not taking 4 bytes, I'm just taking 4 bits. This will be dropped off.
0.
If it were 4, it will come here and it will become 16, but for now, it's a 0. Now, if this is a signed integer, this will become actually a negative number because your most significant bit is set.
1 now.
In actual computers, it will be 4 bytes, let's not get that. But what I'm trying to say is, when you do enough left shift, if it's a signed integer, you will end up changing the sign of the number. So just be careful with that. Now let's do a division starting from 8. This is 8. When I right shift, it will become 0, 1, 0, 0. This is 4. 1, 0, 0, 0, 1, 0. This is 2. 1. This 1 dropped off. It doesn't work for just one integer, it will work for anything. What is this? 13. So when you right shift 1, it will become, this is 6. Right shift 1. This is 3. This is 1. You see that every time the last one becomes this. sense? We start with the problems. So this number, is it 1 or 8?
It's 8.
Why?
Because we are not considering it as a signed integer.
Okay.
Considering
Let's say
the
it's not
integer.
signed. Let's say this is unsigned. After that, is it 1 or 8?
8.
Why?
That is the 8.
So you're considering this to be MSB, right? And this is your LSB. What if this is LSB and this is MSB?
And the
Least
0
significant bit.
Then it is 1.
Yeah, if that is the case, that is 1. If this is LSB.
So this is your most significant bit. So this is 8, 4, 2, 1. Correct?
Yes.
So when you have your LSB, MSB to the leftmost and LSB here, you start like this, right? 1, 2, 4, 8, 16, 32. Correct?
Is it a representation of a number or what?
This
This
one?
is one number, right?
No, this is not
And you
one
are counting
number.
the left and most.
This is one number.
Right.
1, 0, 0, 0 is
So
one
this is
number.
the one number
Yes.
that we are representing the binary.
Yes.
So
Now this could be read like this or it could be read like this. Correct?
yeah, right.
When you're reading it like this, it is 8.
Yeah.
But when you're reading it like this, it is 1.
No,
Yes.
8 and 1. When we are reading like
This
this,
is your
then-
most significant bit. This is your least significant bit. At that point in time, this is 1, 8. Correct?
if I am reading like this, then this is
Don't
one.
go by direction. This is your most significant bit. This is your least significant bit. This is 8.
Yeah, sure.
This is your least significant bit. This is your most significant bit.
This is
That is, then it's 1.
1, correct.
Okay. So, do you know these notations? It's called Indian,
I forgot.
big Indian, little Indian.
Yeah.
Which one is big Indian and which is little Indian?
Mostly compiler.
This is called little Indian, this is called big Indian.
पर कुछ compiler जो वाले पे चलते हैं नीचे वाले पे तो
In which scenario will you call from LSB to
पर mostly ऊपर वाले जो 8 है
This is little
जो
Indian,
use करते हैं normally
this is big Indian.
Indian.
NDM
Indian.
ENDIAN
Oh.
Just let me confirm once more.
What is that?
In comparison.
I have to think it's
Okay, so
is it reverse that is little endian so the generally we use in our
yeah,
that is little
Oh, after reverse thing.
yeah, I get confused too. I don't remember it on the top of my head.
so we have to remember just we are using little not the big
Don't just write this program that I'm telling you and
Yeah,
then
that is-
figure out which one.
If they ask this kind of stuff, do you need to ask them?
no generally C# is C#
Yes.
and
Everything
modern
is little Indian. When you go to microprocessors and everything, that is big Indian.
that is big
Sorry, for your
hardware design VLSI
hardware, yeah, well, embedded. Sometimes embedded are big Indians. Usually,
Yeah,
everything is
only in
big
certain cases, not in
Not
every-
in every.
Then we don't.
Anyway, so how would you find out if it is little Indian or big Indian?
We will have to make a program.
Good start. You're half done. Now what's the program? Okay. So, how big is an int? 4 bytes.
That depends on language.
And char? 1 byte.
Yeah.
Okay. So let's say you have an integer a. Yeah. So 4 bytes would be.
In C++,
Let's say this is each 1 byte. Okay. Now, if I were to set this to 1, if it is little Indian, it will become like this.
Yes.
I'm not writing all the zeros. Now, if for the same integer you were to take one character at the end of it or at the beginning of it, then will you know if it is little Indian or big Indian?
Yes.
One character.
One character.
Not necessarily.
Why not?
Because, okay, you are
Same
representing the number 1 here.
Yes.
Does not mean that every time the number 1 will be given.
No, you are setting it, right?
If there is a signed bit there, if it is just 1 in the beginning and 1 in the last.
No, but
No,
this
but
is plus
this
1,
is
right?
what
So
you
you are, in this case, irrespective of everything, your most significant bit will always be 0 because it is a plus 1.